Let's try this practice problem together. Now, if you'd like to try it on your own, go ahead and pause the video right now. Otherwise, let's jump right into it. If y is greater than 5, we need to find the equivalent expression to this one right here. And down below, these are our 4 answer choices. I'm going to go about solving this problem using 2 different methods. For this first method, let's just go ahead and use substitution. We know that y has to be greater than 5, so let's just let y equal something like 6. Let's go ahead and swap out y for 6 for the original expression. Plugging in 6, we're going to get this expression right here. Going ahead and subtracting 6 minus 4 and 6 minus 3, we get this more simplified expression. Then to add together this 1/2 and 1/3, we need common denominators. That's going to be 6. So we can multiply the 1/2 by 3 over 3 and multiply the 1/3 by 2 over 2. Rewriting these fractions with common denominators, we can write 3/6 plus 2/6. Now that we can add them together, we're going to have 1 over 5/6. And remember, 1 over a fraction or 1 divided by a fraction is just going to simplify down into its reciprocal. This is equivalent to 6/5. Looking at our answer choices, A can't work because it's not a fraction, and B can't work because it's also not a fraction. That leaves us with choice C or D. If we plug in 6 for C and it works, then that's our answer. If it doesn't work for C, then we know that D must be the answer. Substituting in 6 for C, we're going to get this expression right here. And evaluating it or simplifying it down, we're going to get 6/5. Based on that, we know that C must be the right answer. And if you look at the expression for answer choice D, notice how it's just the flipped version or reciprocal for answer choice C. That means if we plugged in 6 to this expression, we would get 5/6 instead of 6/5. So while that's how you solve this problem using substitution, let me show you another method where we keep it as a rational expression. So here's our original expression, and let's focus on the bottom half. To add these rational expressions together, we're going to need common denominators. Since they're relatively prime, we're going to multiply the left fraction by y minus 3 over y minus 3, and the right fraction by y minus 4 over y minus 4. Because y minus 3 over y minus 3 and y minus 4 over y minus 4 are just equal to 1, we can do this without changing the value of the expression. Multiplying these fractions together, this is what we're going to get. Just like we planned, they have common denominators. Since the bottom fractions have common denominators, we can add them together to write one fraction. This is what we're going to get. Combining like terms for the numerator, we're going to get 2y minus 7, and foiling out the denominator or distributing, we're going to get y squared minus 7y plus 12. Since we still have a complex fraction where we have 1 over this entire mess, let's go ahead and rewrite it from left to right. Rewriting this expression from left to right, we have 1 divided by this 2y minus 7 over y squared minus 7y plus 12. And multiplying by the reciprocal, we can write this as 1 times y squared minus 7y plus 12 over 2y minus 7. Dropping that 1, we get this final simplified expression of y squared minus 7y plus 12 over 2y minus 7. And just like earlier, this leads us to our answer choice of C. So for this particular problem, I think using substitution is the way to go, but in case you just wanted to brush up on learning rational expressions, hopefully this was helpful. If you gained any value from this video, please consider giving it a thumbs up, and as always, keep up the great work, and I'll see you in the next one.